Hello everyone, welcome to video 1 of my GenAI series. So you see every videos in GenAI are either jargons or it basically assumes that you have a PhD in machine learning. But there is a gap where people talk about how engineers use it, what GenAI means to engineers, and how can you run a production system with GenAI applications. So my videos are targeted for those kind of stuff, and without wasting time, let's get started for video 1. GenAIs are basically a next token predictor. Why I am saying it is we can see the flow below. First is you give the text as an input, and from there the text goes to tokenizer. Tokenizer is something which converts text to numbers. Basically those are token IDs. Now from the tokenizer, these token IDs goes to transformer. Transformer has 70 plus billion parameters which are trained on vast text data. Each token predicts, given everything before me, what token is most likely next. Now from the transformer, we generate output tokens, and output tokens are generated one at a time. From the output token, it goes to detokenizer. So what detokenizer does it converts numbers back to text, and eventually we get response as text. So initially we have given prompt as text, we are getting response as text, and in the middle tokenizer, transformer, detokenizer, these things are working. Generative AI models basically generate new content following this strategy. The new content can be text, image, code, audio, anything. It doesn't only clarify, classify or predict, it generates. So that is the reason it is called generative AI. Generative AIs are basically non-deterministic. It is probabilistic but not deterministic. What are deterministics? Deterministics are traditional code. Like if we give same input, we get same output every time. Generative AI samples from a probability distribution at each token. Same input can produce different output at different runs. And in case of generative AI, there is one important thing which is called temperature. This temperature can be set from 0 to 1. At temperature 0, the model picks the highest probability token every time, most deterministic. At temperature 1, it samples more broadly, more varied output. So when using generative AI in production, we prefer to use temperature at 0, because for any production system that parses Claude's output programmatically or any generative AI system's output, always use temperature 0 to minimize run to run variance. Now one important thing what we need to understand is what generative AI is good at and what generative AI is bad at. So generative AI is good at understanding and generating natural language, summarization and extraction, code generation and review, following complex instruction, reasoning over text, and adapting to formal requirements. But it is bad at precise arithmetic, counting characters or tokens, real-time data, guaranteed consistency, variable facts without grounding, task needing 100% determinism. Now one mental model that prevents mistake which we can follow is, first, it's a reasoning and language system, not a database. So the biggest mistake engineers make is treating generative AI is like a database or a rule engine, but it isn't one. Second is use it where human level language understanding is the hard part. So that's where GenAI earns its keep, language reasoning, not lookup. Third is don't use it where exact correctness is the only metric. So task needing guaranteed verifiable 100% correct output are the wrong job for a probabilistic model. It might be correct at temperature 0, but you can't be 100% sure. You should have another human in the loop or somehow the other way to measure the result. So if someone asks me what is GenAI, I would be talking about these three things. First is it's a trained next token predictor. Tokenizer, transformer, detokenizer. These three are the building block. Intelligence emerges from patterns learned across hundreds of billions of words. Second is it is probabilistic, it is not deterministic. So we should use it as per our requirement depending on what we want. It might be definitive answer or it might be a probabilistic answer. We should use it wisely. Third is, it is excellent as language reasoning, poor at arithmetic and guaranteed correctness. Understanding the mental model prevents most integration mistakes.